Hello, and welcome to part 2 of our writing a simple program in C++ using Android. Last time we used used the Android Mobile C developer environment to make a simple Hello World program. It's a simple program that just spat out a little output that was embedded in the program when we wrote it. This time we're going to accept input from the keyboard, and when we accept input we need to put it somewhere. With Hello World we just had the output written into the program. But let's review Hello World for a minute, and let's see what happens when you have an error in your Hello World. Errors are going to be a very important part of every programmer's life, and you should get used to seeing them. Okay, so here's the Hello World output from last time, and this is the program, but there's an error in this one. Hopefully you can spot it. It's a we tried to run the program and we got this error message because the initial quotation mark for Hello World was omitted in this version. Actually, the H was also omitted, but the missing H doesn't matter. The missing quote, however, will stop the program from running. This is a compiling error. The program will not ever run until that quotation mark is put back in. We get a compiler error, which means the computer will not assemble the program to run because the program has a fatal flaw. In this case, it was missing the quotation mark. The compiler is the part of the program which translates the text that you write into machine readable code. And if the text you wrote didn't adhere to the rules of C, the translation doesn't occur because the computer doesn't know what to do. But the computer will give you feedback to help you fix a compiler error. There are other kinds of errors that we will encounter, or actually we didn't fix the error in this slide, but this slide has the quotation mark in it, but it's missing something else. It's missing the semicolon at the end, and that's the error message we get. Says, where's the semicolon? So again, this is a compiler error. You'll see in the feedback from the compiler error, you see expected semicolon after expression. Very helpful feedback. Tells you exactly where it is, points you a little green line, green arrow, and that's helpful. Sometimes the information the compiler provides you is not as helpful. But common compiler errors that will occur all the time: missing semicolon, quotation mark, or brace, or extra semicolon, or extra quotation mark, extra brace. An extra quotation mark or an extra brace also, since quotation marks, braces, and parentheses always occur in pairs, the computer is looking for a matching one that doesn't exist. So a missing semicolon and an extra, or a missing quotation mark or a missing brace implies that there's an extra one, or vice versa. That's just a funny way of looking at the logic. But the compiler will point these out, and you can insert or remove the offending mark. So that's compiler errors in Hello World. You'll remember Hello World had a little thing that said C out, and a couple of angle brackets, and then quotation marks that held the information Hello World. C out with angle brackets going left sends content to the screen. C in accepts content from the keyboard. And this is a big step because now we can affect the computer by adding something of our own. You'll notice the little angle brackets go the other way. But what do you do with CN data? You type in the data, it has to go somewhere, it has to be held somewhere so that the computer can process it. It gets put into a variable where it's stored for further use. Different kinds of variables. Today we're just going to use the int variable for integer, meaning any number up to about 64,000, but it won't have a decimal point. Just integers, 1, 2, 3, 4, 5, etc., and negative as well. But they'll be whole numbers. There are other types of variables. There's a variable for holding letters, a variable for holding letter numbers with decimal places, and something called a string, which will hold an entire word. But right now we're just going to use integers. And cin stores your data in a variable, and it's kind of like algebra. You had a equals 7, and b equals 3. 7 plus 3 equals 10, a plus b equals 10 in algebra. And like in algebra, you get to name the variable. The only problem is you can't use a name that's, you can't use a word for the variable that is being used elsewhere in the program for something else. That's the rule. For that reason, I use silly variables. I use silly variable names because they stick out. I'm going to be using Peanuts characters. Okay. So here's our program. I've in the int main, the instructions live, just like with hello world. The bottom line, or line number 9, the fourth line of the instructions inside the brackets, looks just like hello world, kind of. It's got more stuff in it, but it's got a C out and 2 angle brackets and then a little information inside quotes. But let's go through this line by line. The first 5 lines are the same as hello world. They're the information which creates the program, place for the program to live. The top 2 are the preprocessor directive. Line 4 is the main function, indicates this is where the main function is going to be. Line 5, the opening bracket, starts the program. And then line 6 says int Snoopy. That means variable, integer variable, and we're going to name it Snoopy. A semicolon at the end of that because it says, Snoopy is the name of our integer variable. And then C out in line 7 is telling the user to enter a number. That's a complete statement, just like hello world ends with a semicolon. And C in will accept whatever the user types in and will store it in the variable Snoopy that has been declared. Hopefully it's an integer. It has to be an integer. And then line 9 will spit out precisely what you entered. Very simple. It will say, what did you enter a number? This is the number you entered. 3 little steps. Ask for a number, get a number, spit it back out. And then the return 0, just like with hello world, tells the computer that the program is over. Here's a diagram. Snoopy is the variable, and the name, variable type is integer, and the name is Snoopy. Cin is the input. You can look at that for a minute. So let's run it. It's asking for a number. Let's watch it run. We enter the number and then it just spits it out again. Kind of looks just like hello world, except there was a prompting for a number, and it was blank, and then we entered the number, and there it was. So let's mess with it, since we did it and it works fine. Well, let's mess with it. What if we put in a y instead of a number? The computer computer doesn't know what to do. It's expecting a number. If it gets a letter, it's not going to be able to handle it, and so it returns a 0. The program kind of works. It works within the limits of how we wrote it, but we did not expect the user to enter the wrong kind of information. We asked him to enter a number, but they didn't follow the instructions. This happens all the time. This is a logic error. It's a flaw in how we design the program. It's not a compile error. The program ran normally. It's kind of like building a car, and if it was a compile error, the car wouldn't start. But the car started fine, but it just only turns left. That's a design flaw. So here's our program again, and just review it for a second. The input goes right back out. It's not very helpful yet. What we'll do in the next lesson is play with the data and then spit out something that we've done to the data. We entered a number, and we want to process the data that we've put in, perhaps combine it with other data. That's what we're going to do. A computer is dynamic. It does something to the data you give it, and might mix it with additional data and give you an output. It does some useful work. So we're going to add two variables together. I'm going to create a new variable, Violet, and Violet will have a value, but it won't be an input value. It's just going to be a value that we declare, and then we'll add Snoopy and Violet and get a new value. Okay, this is what we had before. Snoopy was the only variable, an integer, and we solicited the value of Snoopy from the user. Now we're adding Violet, and we're giving Violet a value. You see the little =7 semicolon? That just means we're assigning her a value of 7. Okay, that's line 7. And down on, then we do what we did before. We ask for input, and we tell them what they input on line 11, just as a courtesy. And then line 12, we output Snoopy and Violet added, and it's just inside the little parentheses are Snoopy and Violet, and they have to be inside parentheses because we need to isolate that mathematical operation from the formatting operations of the going on elsewhere in the line with the double brackets and the display information inside the quotes. And Snoopy and Violet is the same as adding 7 plus whatever the value of Snoopy is that the user gives us. So we run it. The user entered 9. We parroted that back. Then we added 9 to 7, and we got 16, and we put that out. The problem is, of course, I entered a semicolon. Why is there a semicolon there? That's an error I only noticed after I put this slide up. The semicolon is inside the quotes, inside the pair of quotes, so it doesn't matter. Elsewhere in the program, it might confuse the program and cause an error. So here it is. No, I didn't correct it on this, but you see, since they're inside the quotes, it doesn't matter. Anything that's inside the quotes makes no difference. The computer doesn't recognize it, just sees it as text. Okay, but here's a look at the program again. We assigned Violet a value, and the user assigned Snoopy a value. And and then we add the two in a separate parentheses expression. So it's pretty simple, but let's do some errors. We did some errors on the hello world. I want to see creating errors is a great way to learn. Computer code is, it doesn't cost anything. You can modify it and modify it again. Modify it again causes no problems, provided you're not doing something, critical with your data. Don't do this at work, but do this when you're learning. What I did with this one was, I don't know if you can spot it, I added an extra Y to Snoopy, not in the first instance of Snoopy on line 6, not in the second instance of Snoopy on 10, not in the third instance of Snoopy on line 11, but in the line 12. Now, the computer knows Snoopy only has one Y, so when it encounters Snoopy with a second Y, it doesn't know what that is. It's a completely different thing to the computer, so the computer is going to give us an error. And you see it caught it and it spit it out and it gave us a compiler error, and it was helpfully highlighted in green. So you would go in and change, you'd hit the back arrow and change the text in the code to reflect Snoopy with only one Y. Okay, here's another error. I gave Violet the value of M instead of a number. And you can't add M to a number. The computer is expecting an integer. Remember, we said an integer was a whole number. And so it gives us a compile error, will not compile. Value M is not an undeclared identifier. It basically means we're expecting an integer, we get an M. That's not acceptable. And so those are two neat little errors. Making errors is a lot of fun. When you have code, you can see exactly how things go wrong while you're preparing to write code that might be useful, so that you can prevent errors from occurring. So today what we did was we accepted input and from the keyboard, and we added it to other values, and we spat the sum out. And so this is kind of useful work. This is how you can use a computer to calculate things, and these equations get very complex. But the steps are all very simple. So thank you. There will be another lesson coming up. We will continue with this, and I hope you continue with it. If you have any questions, just leave them in the comments. Thank you for joining me today.